Dr. Elion Marek watched Earth turning under him, a slow blue sphere in the window of the orbital lab. City lights outlined the continents like circuitry. White storms circled over the oceans. Here and there, thin silver lines of orbital elevators climbed away from the equator, carrying freight, ice, and people between ground and sky. Elion barely saw any of it. Most of his attention was on the holographic globe in front of him, a ghost version of Earth, stripped of oceans and continents, sliced open to reveal its interior, crust, mantle, and core, painted in shifting colors of heat and density. The colors were all wrong. "Run it again," he said. The station's analysis AI obeyed without comment. The globe blinked, reset, and the data stream replayed. Neutrino flux counts scrolled along the side in thin columns of light. Gravity anomaly curves drew themselves in the air. Seismic wave travel times spun around the equator like bracelets. Again, the same pattern. A quiet hole in the data under the Indian Ocean. A strange, smooth region interrupting the noisy chaos of normal mantle convection. "Noise," Elion said under his breath. "You're supposed to be noise." The lab's lights were dim to help people see the holograms. That meant the only bright things in the room were instruments and Elion's own reflection in the window. Tall, slightly stooped, hair starting to grey at the sides, dark circles under his eyes that even station filters could not smooth away. He looked older than his 58 years. The door behind him slid open. Soft boots crossed the floor. "I thought you were off shift," said Dr. Sarah Haldane. Elion turned. Sarah was shorter, her hair tied back, her station jumpsuit half-zipped as if she had rushed here from sleep. Her badge flickered with her role, Seismology Lead. The badge under it, Council Liaison, was darker, only lit when needed. "It's quiet," Elion said. "Too quiet." "Oh good," Sarah sighed. "You're naming anomalies again." Elion smiled a little, but did not look away from the holographic Earth. On the globe, India and Madagascar floated above blue, but the blue was only a skin. Beneath it lay the real thing that had held his mind for the last 5 years. A strange region of the mantle under the Indian Ocean, where normal rules broke. The Indian Ocean Void, as younger researchers called it, as if irony could hide concern. Half joke, half problem. "Null zone is still there," Sarah said, walking closer. 5 years of data, same patch of nothing. "I would call that some very stable noise." "It is not nothing," Elion said. "Look at the waveforms from the last Sumatra microquake." He flicked his fingers through the air. The globe zoomed in, then sliced along a vertical profile from Africa to Australia. Lines of seismic waves, color-coded, appeared like thin ribbons moving through layers of rock. Sarah squinted. "They curve more than predicted." 9-B curve away from the void, Elion said, as if it is more rigid than it should be, or more empty, or both. "Or we still do not know every detail of how the mantle behaves," Sarah replied. Her tone was gentle, not mocking. "After 3 centuries of seismic science and a century of neutrino tomography," Elion asked, "we map exoplanets more clearly than this piece of our own mantle." Sarah laughed. "Careful, you're starting to sound like the outreach feeds. We know more about distant galaxies than the world beneath our feet." "It is true," Elion said, "and it is getting in the way." Sarah's eyes softened. "In the way of what?" "Of sleeping," Elion said. He waved again. New data appeared. A grid of neutrino flux values, fine as lace, running through different depths. The same old blind spot sat where it always did, like a scar. "I know the legacy scanners did not have the depth resolution," Elion said. "I know everyone says it is an artifact, but it has a stable shape. Artifacts drift with hardware, with calibration. This does not drift, because we correct for it in the models," Sarah said. "You help write those corrections, remember?" "Yes," Elion said, suddenly tired. "That is the problem." They stood in silence for a moment, watching lines move through rock tens of thousands of kilometers below. In the early 21st century, people had guessed what Earth's interior looked like from the way seismic waves moved after earthquakes. It had been like trying to understand a living animal by listening to bones crack and thumps run through flesh. Now, in the mid-25th century, the view was far clearer. Neutrino sources in orbit, and in buried deep ice labs rained streams of nearly massless particles through the planet in controlled beams. Arrays on the other side counted the particles that came through. The way different layers bent, scattered, or absorbed neutrinos showed their density and composition. Quantum gravimetric sensors, orbiting at fixed points, measured tiny changes in local gravity as mantle plumes shifted and plates ground past each other. Massive AI models ran all of it in reverse, reconstructing 3-dimensional maps of temperature, phase, and motion deep below the crust. Still, the planet lied. "New scanners come online in 2 hours," Sarah said. You will finally get your extra depth. Elion's expression did not change. If the pattern goes away, I will send a retraction to every journal I have annoyed in the last decade. And if it does not go away, then I will have to annoy more journals, Elion replied. Sarah smiled without quite meaning to. Try to get some rest before the light storm jump. You will think better. He nodded, but his eyes were already back on the data. Sarah left. The lab doors sealed. The soft hum of life support, fans, and low-G field coils filled the quiet. Elion zoomed out the model and switched to a different view. Now the mantle appeared as a thick, transparent shell, shot through with slow-moving tongues of hotter and cooler rock. The Africa superplume, bright and rising. The Pacific quiet zone, the subducted slabs like sinking rafts of denser crust. And there, under the central Indian Ocean, a clean, continent-sized patch where data went wrong. He pulled up the legacy history. First hints in late 22nd century seismic inversions, then clear evidence with the first-generation neutrino imaging suites in the 2300s. Scientists had argued, calibrated, recalibrated, lawns of papers had been written. Eventually people had sighed, named it the Indian Ocean Void, folded it into mantle heterogeneity, and gone back to more comfortable puzzles. Except Elion. He started a fresh recording, dictating notes for his future self and the station log. 2441.179 standard, he said. His voice sounded dull and flat in the empty lab. Subject: Indian Ocean Deep Anomaly. Personal tag: The Planet That Lies. I have rechecked data from 8 independent arrays and 3 different simulation stacks. The null pattern is phase stable across at least 30 years of records. Apparent lateral motion is less than 2 kilometers per decade, which is near zero for mantle convection. Boundaries are too clean. Natural mantle flow does not form perfect ovals of constant anomaly strength. It curls, it twists, it breaks. He paused, catching himself before he chased the same argument again. In 2 hours, he said instead. First test of the deep penetration neutrino system comes online. Resolution down to the lower mantle. If there is any structure there beyond simple density weirdness, this should see it. He stopped the recording. Outside, over the curve of Earth, a bright flare marked the burn of a fusion barge as it pushed cargo up the sky tether. Far below, the Indian Ocean gleamed, a flat mirror in daylight, hiding tectonic scars and mid-ocean ridges under 5 kilometers of water. The light storm engine was not a storm, and it had nothing to do with light. But humans named things for poetry long after they understood the physics. In reality, the system was a network of upgraded neutrino beams and detectors. Narrow, coherent neutrino streams fired from orbital platforms cut through Earth, passing mindlessly through rock and iron with barely any interaction. On the other side, giant detectors in vacuum-sealed boreholes counted the few particles that scattered with electrons and nuclei inside the planet. By linking beams and detectors in a moving schedule, AI could scan the interior like a doctor scanned a body with X-rays or MRI. Deep penetration, the new layer for the system, used higher energies, better collimation and quantum-tuned detectors. The goal: resolve fine features in the lower mantle and near the core mantle boundary, down to scales of a few kilometers. That is the theory, Elion said, strapping into his station chair as the activation countdown neared zero. In practice, we will fry half our grids, waste 2 years of calibration, and get asked to return all the grant money. Your confidence is inspiring as always, the station AI replied in its dry standard voice. Would you like a sedative before first light? No, Elion said. I want data. Data may cause symptoms of sleeplessness, fixation and social withdrawal, the AI said. Side effects include email storms and committee hearings. Those are chronic conditions, Elion said. He pulled the hologram closer, shrinking Earth to basketball size and setting it to real-time update mode. Lightstorm anchors around the planet came online in sequence. Tiny icons lit up around the equator and at the poles. Neutrino sources, detector arrays, calibration satellites, vacuum stations sunk into stable cratons on all continents. In the Indian Ocean, a new cluster snapped on, 3 orbital emitters and 4 deep-bore detectors under Madagascar, Western Australia, southern India and Antarctica. Begin test sweep, Sarah's voice said over the internal channel. Index OM1 through OM112. On the globe, slender invisible beams traced from orbit through Earth's interior, each labeled with a string of codes. Detector responses crawled up as faint lines at the far side, then sharpened as dynamic filters kicked in. Neutrino flux holding within design range, the AI said. Detector noise minimal. First pass reconstruction in 5 minutes. Elion watched, fingers drumming lightly on his armrest. Years of planning and incremental demos had led to this moment. Governments had compromised. Resource councils had agreed. The fusion mining consortiums had contributed infrastructure, partly to secure better maps for their own deep well projects. Dozens of careers rode on deep penetration working. Elion's career rode on it finding something it should not. Sarah floated into his peripheral vision on his private screen, patched in from another lab. "You watching the same thing I am?" "Yes," Elion said. "I can always tell by the tension in your neck." "Stop looking at my neck," Elion said automatically. The AI gave a quiet chime. "First pass reconstruction ready," it said, displaying. The holographic Earth flickered. For a heartbeat, deep layers went dark. Then, slowly, they filled with color. Where earlier maps had been coarse, smoothed by lack of resolution, the new layer came in sharp. Hotter plumes showed as narrow tongues of red. Older, colder subducted slabs revealed thin coils of blue, looped like dropped ribbons. Fine-scale structures, small cratonic roots, minor anomalies appeared for the first time. Elion leaned closer. The Indian Ocean region brightened. At first his heart sank. The void looked like it was filling in. New details, gradients, subtle shifts in density and phase. "See?" Sarah said. "Just needed better tools." "Wait," Elion said. He adjusted thresholds. He told the AI to flatten natural convection patterns and highlight deviations from expected models. Large patches faded, others sharpened. Under the Indian Ocean, a shape came into focus. It was not a hole, it was a body. "AI Rue," Elion said quietly, using the station's research mode name. "Filter the Indian Ocean anomaly for structural symmetry. Use three-dimensional spherical harmonics. Override default smoothness penalties." "Warning," the AI replied. "Requested filter may produce false positives for pattern recognition." "Do it," Elion said. He pulled up the historical model alongside the new. The old map, a smear of low-contrast anomaly, weird but shapeless. The new map, a sharper volume with boundaries that curved in smooth, intentional lines. After the AI's filter, the volume lit up. Edges glowed, internals separated into layers. Sarah stopped talking. The anomaly was not a random blob of mantle heterogeneity. It had distinct boundaries, roughly oval in plan view, with straight segments and repeating angles when sliced. It had internal grids, regions of alternating higher and lower density in a repeating pattern like a lattice. It was continent-sized, 3,000 kilometers across at its widest, about 500 thick. It sat not at the core mantle boundary, but higher, nested in the lower mantle like a stone in gel, held fast by surrounding rock. "Elion," Sarah said, voice thin. "Is that a reconstruction artifact?" "I do not know," he said. AI Rue, overlay expected mantle convection streamlines. Lines appeared, showing the standard model of flow in the region. Rising material under Africa, sinking slabs near Indonesia and the Sunda Arc. Most of those lines curved around the anomaly, then met again on the other side. "It is blocking flow," Elion murmured. "Or diverting it. But the smoothness," Sarah cut in, "show the power spectrum of density variation inside the volume. Compare to adjacent mantle." The AI obeyed. Two graphs floated above the globe. The one for normal mantle looked like noisy static peaks and dips spread in a complex, irregular pattern. The one for the anomaly volume had thin, sharp peaks at regular intervals, repeating frequencies, periodic structure. "That is not geology," Sarah said. Elion's heart was beating too fast. He forced himself to breathe. He isolated a central slice and magnified. Now the structure looked like a city seen in cross-section. Repeating blocks, vertical and horizontal features, diagonal braces. There were curved regions at the top and bottom, denser shells, possibly reinforcement. "This cannot be," Sarah said. "Check calibration," Elion said. His voice sounded oddly calm to his own ears. "Cross-validate with gravimetric data and seismic inversion." "That will take a few minutes," the AI said. "Take them," Elion replied. He sat very still, hands locked around each other. Old myths passed through his thoughts, half remembered from childhood feeds. Lemuria, Mu, lost continents swallowed by the sea, civilizations forgotten beneath waves and time. He had studied geophysics in part to kill those ideas. Continents did not sink like ships. Plates rode on mantle flow. Basalt did not simply vanish. The solid parts of Earth moved slowly, according to rules that could be written on a board. Yet here, deep under the Indian Ocean, was something that every rule said should not exist. A vast, solid body, stiffer and denser than expected, with internal structure that looked organized, not chaotic. The AI chimed again. "Cross-validation complete," it said. "Gravimetric anomalies align with reconstructed density pattern within error bounds." Seismic inversion from existing quake catalogs supports presence of a high-rigidity region consistent with deep penetration data. Calibration errors are unlikely to produce observed symmetry. State likelihood of natural geological origin, Sarah said, voice very tight. Using current mantle convection and phase transition models, the AI said, and assuming no unknown phase of mantle mineralogy, estimated probability that structure arises from natural processes is less than 10^9. So you are saying, Elion said slowly, that it is almost certainly engineered. Silence. The word hung between them. Engineered. Engineered by what? By whom? The station went into quiet lockdown automatically, as it did for any finding tagged with multiple planetary concern flags. Unnecessary channels closed. External communication queued for review. Inside, teams gathered. Elion found himself at the center of a wide table in Conference Sphere 3, strapped into a rotating seat that allowed everyone to face each other in microgravity. Around him floated specialists patched in from Earth, tectonics experts in European gravity wells, neutrino engineers in Antarctic arrays, mantle chemists on a Pacific Ocean city, and a few planetary council observers whose titles did not include the word science. Most eyes were on the shared model that hung in the center of the sphere, the new map of the Indian Ocean anomaly, slightly smoothed to avoid panic but still impossible to misread. Councillor Jian from the Pan-Indian Federation spoke first. "Let us be clear," she said. Her face was lined, her hair silver, but her eyes were sharp. "You are not saying there is a hollow under the ocean, correct?" Elion shook his head. "No, it is not a cavity. It is solid, very solid, higher effective rigidity than surrounding mantle." "Then what is the meaning of engineered?" Jian asked. Her accent was light, her words clipped. Sarah answered before Elion could. "The internal structure," she said. "Natural mantle shows irregular variation at Mukhthalif scales. This volume has repeating patterns, regular spacing of density highs and lows, symmetry planes, corner angles that cluster around simple ratios. These are signs of design, not random convection." "But design by who?" asked Dr. Tsai, a mantle physicist from the East Asia continental ring. Elion stared at the model. It was strange how much the brain tried to see familiar forms. His mind wanted to call some blocks buildings, some curves domes, some cross-braced sections bridges. He forced himself to think in terms of load-bearing shells, stress paths, phase boundaries, and thermal gradients. "We do not know," he said. "We cannot even be sure it is biological. It could be an ancient human energy project." "It is not," said Dr. Naimakev, a historian of technology. "We have continuous archaeological and geological records for the last hundreds of thousands of years at least. Nothing like this. No hint of a civilization capable of that scale. Certainly not one that could place a structure this deep." "Then aliens?" Councillor Jian asked flatly. "Not likely," said Dr. Tsai. "If an interstellar civilization can build inside mantles, it does not hide. It does what it wants openly. Also, no trace of impact or external delivery. This looks grown with the mantle, not implanted from outside. Could it be a leftover of some early planetary differentiation process?" suggested a young researcher from the African Creighton lab. "A stable root of a proto-continent?" "The symmetry argues against it," Sarah said. "So does the alignment with ancient supercontinent outlines." She flicked data into the shared space. A reconstruction of Earth's plates over hundreds of millions of years appeared, continents sliding, splitting, merging. "When Gondwana and later land masses broke apart," she said, "this region sat under an intersection of several tectonic blocks. That by itself is not strange. What is strange is that no slab seems to have passed through this volume. Subduction lines bend around it. Elion took over. It is as if something was already there, resisting being dragged down. Mantle flowed around it, plates rode over it, but the volume held." Councillor Jian stared at him. "For how long?" "At least 200 million years," Elion said. "Maybe more." The man's soft laugh from the Pacific segment was dry as sand. "So you are suggesting there has been a solid, artificial continent-sized structure inside Earth's mantle since before mammals became dominant?" "I am not suggesting," Elion said. "The data is suggesting. I am only reading numbers." "That is not reassuring," Councillor Jian said. The room fell into a low argument, voices overlapping. The AI kept track, tagging threads, posting synchronous transcripts into side windows. Some argued for slow-release data to the public. Some insisted on immediate open posting. Others wanted more checks, more scans. Elion barely heard them. His attention had drifted to a side display, a simple temporal graph showing the centroid position of the anomaly volume over time, as reconstructed from old data and now refined by deep penetration. A small white line traced the center's latitude and longitude over decades. It was not fixed. Very slowly it moved. He tapped the graph, magnifying the motion, filtered out noise, smoothed out modeling errors. He told the AI to estimate position change over 70 years. A new plot appeared, a tiny curve just a few kilometers long. The structure was not staying put. It was migrating. Elion? Sarah's voice cut through the noise. What is it? He did not answer right away. He was already calling up another display, strain fields in the surrounding mantle, vector plots of stress directions. The structure's motion was not random drift. It had a direction, a tilt, not straight up, not straight sideways, more like a slow roll, as if the whole volume was rotating, turning one side toward the crust above. Elion? Sarah said again, sharper. Look, he said, sending his plot into the shared space. The graph appeared next to the main model. The chatter in the room faltered. What are we seeing? Asked Dr. Sci. Centroid motion, Elion said. I asked AI Ru to reprocess decades of older neutrino and seismic data with the new structural model as a fixed template, then estimate its best fit position at each point in time. The motion is small, yes, and errors are large, but the trend is real, and when you average over time, he summoned another overlay, a small arrow from the center of the anomaly pointing a few degrees upward and eastward. Direction? Sarah asked, though he suspected she already knew. Toward the surface, Elion said. Very slowly, a few centimeters every year at most, but not in a straight line, more like a controlled rotation, easing stress. That is impossible, said Councillor Jian. Mantle convection moves plates, not the other way around. A continent-sized object cannot move itself independently of the flow, unless, Sai finished quietly, unless it is interacting with the surrounding rock in active ways, adjusting its own buoyancy, shifting phase states on demand, using magnetic coupling or other mechanisms to climb, like a submarine using ballast tanks, Sarah said softly. In solid rock, silence settled over the confront sphere. Outside, Earth still turned, looking peaceful and ordinary from orbit. Inside the planet, a buried shape was moving. Not fast, not in any way that surface life could feel yet, but moving. Elion felt a strange mixture of terror and excitement, like standing at the edge of a cliff and seeing, far below, a shape rise from dark water. Run forward projections, Councillor Jian said suddenly, using current motion and possible phase change strategies. How long before it intersects the lithosphere, if this trend holds? That depends on unknowns, the AI said. Assuming linear extension of current drift and rotation, time to first contact with lower lithosphere is on the order of 300 to 600 years. A sigh of relief moved across some faces. Centuries, not an urgent crisis, something for future generations. But, the AI added, if motion is part of a larger activation cycle with variable rates, timelines may shorten significantly. Initial signs of structural adjustment at the mantle lithosphere boundary could appear much sooner, on the order of years to decades. What kind of signs? Sarah asked. Non-random changes in stress fields, the AI said. Earthquakes with unusual focal mechanisms, smooth large area uplift or subsidence without expected magmatic sources, changes in geomagnetic patterns, if structure interacts with core field. Elion thought of all the odd reports from the last 2 decades, the slight misfits in earthquake models, the unexplained drift in certain gravimetric readings, the small but growing list of anomalies that most people had assumed would be solved later. His mouth felt dry. We have already seen some of those signs, he said. No one answered. He felt the weight of the planet under him, as if gravity had thickened. The Earth people thought they knew was a thin surface story, a crust, a skin. Beneath that skin, something vast had been sleeping. Now, with every new data packet and beam, it looked less like a natural quirk and more like intention. Whoever built that, Sarah said at last, did it a very long time ago. If it has been stable for hundreds of millions of years, why move now? Elion stared at the slow arrow creeping toward the crust. Then he thought of another dataset he had not yet pulled into this analysis: human fusion mining. In the last 50 years, deep-bore fusion drills had begun to reach far below what previous civilizations had called safe. Vast shafts burned into the upper mantle to access rare isotopes, high-grade minerals, and direct thermal power. Most of those were far from the Indian Ocean, set in stable cratons and continental interiors. But not all. IRO, Elion said. Overlay global fusion mining sites and deep geothermal tap points on this model. Focus on anything within lateral range of the anomaly. Dots appeared on the globe. Red for fusion mining, orange for other deep taps. At first, it looked like nothing. Then he saw a small cluster along East Africa, another under Western Australia. Both sat at depth ranges where seismic waves could reflect and refract through the mantle along curved paths. Could our activities have disturbed it? Sarah asked quietly. Unknown, the AI said. Correlation does not imply causation. There was that dry comfort again. Elion watched the long, slow arrow. He thought of deep systems under pressure for vast amounts of time. How a little disturbance, a nudge at the right moment, could shift the balance. If that structure was in some kind of suspended state, he said slowly, choosing simple words for an idea that resisted them, then changes in mantle stress, temperature, or magnetic field could trigger a transition. Earth's field has been drifting. Fusion mining adds small local changes. Climate repair has altered mass distribution on the surface. Taken together, they might have nudged a very old system toward activation, Sarah finished. Councillor Jian pinched the bridge of her nose. You are telling me, she said, that humanity might have accidentally rung the doorbell of a hidden continent inside our own planet. No, Elion said, surprising himself. I think we might have turned off an alarm, or broken a lock. It may have been set to wake regardless. We might have only changed the timing, or the conditions. Speculation, Dr. Tsai said quickly. Yes, Elion agreed. But so is any model before it is tested. We can check. We have time, but not much. We need to monitor every deep quake, every gravimetric drift. We need to push Lightstorm harder, build more detectors, refine the picture, and... He hesitated. And what? Sarah asked. He looked at the rotating volume in the center of the room, a continent that was not a continent, a structure turned inward, wrapped in rock and time. If it was engineered, then it had builders. If it was moving, then whatever directed that movement might still exist. Or something left behind, a machine, a system, a biosphere. We should design signals, Elion said. His own words surprised him. Modulated neutrino beams, controlled seismic pulses, something that could be recognized through that much rock. Signals? Jian repeated. To what? Elion looked up, meeting her eyes. To whoever is down there, he said. If this is not geology, then Earth is not just ours. And if it is waking up, we would be foolish to wait in silence and hope it ignores us. The room held its breath. Outside, perfect clouds drifted over a quiet Indian Ocean. Inside, instruments saw through water and stone and slowed rock. They saw grids, shells, repeating patterns. They saw a buried continent that bent waves and fields in unnatural ways. They saw motion, slow, careful motion. The planet that everyone thought they knew had lied by omission. It was not just a ball of rock and molten iron carrying a clever species on its skin. It was a shared home or a contested space that held more history than humans had guessed. Deep below, in heat and pressure beyond any surface habitat, something old had started to rise. Humanity's hidden rival, Lemuria's long sleep ends. Long sleep ends. The first public maps of the buried structure went out 40 hours after deep penetration came online. They should have taken longer. Security tags, review queues, council votes on paper, all of those stood between raw data and mass release. In practice, too many people had already seen the anomaly. Too many labs on too many networks had grabbed the transmission. Someone leaked. 3 different citizen science forums mirrored the images before any council vote finished. A climate influencer with 50 million followers posted a colorized version of the structure with the caption, "There is a continent-sized machine inside Earth, and it is moving." After that, control was a fantasy. Still, before the real chaos started, there was a brief window where a smaller group tried to understand what they were looking at. Elion spent those hours in the Indian Ocean Deep Earth Task Group. They called it IODET for short. It was not one team, but a cluster of linked teams spread across orbit and surface. Seismologists, mantle physicists, materials scientists, paleoclimate experts, astrobiologists, and because people could not resist, a few myth and history scholars. They met in a virtual hall shaped like a long curved gallery suspended in black. Earth hung below as a constant reference. Elion floated at his assigned station, a ringed platform with adjustable tools. His hands moved through controls only he could see, but the shared model in the center responded when he changed something. "Let us start from what we know for sure," said Dr. Naimakev, who had taken on the role of moderator. "Not guesses, not stories, hard data." She pointed a stylus at the model. "Fact, there is a continent-scale volume in the lower mantle, roughly oval, thicker in the middle, with smooth boundaries and internal patterns that show high symmetry. Fact, added Dr. Tsai, this volume has higher effective rigidity than surrounding mantle. It diverts flow. It has done so for at least hundreds of millions of years. Fact, said Sarah, it is moving now. Very slowly but in a consistent direction, with what looks like controlled stress management. Fact, said an older paleoclimate specialist, Dr. Irina Volkov. There are gaps in the surface record that we have never fully explained. Periods where something large must have changed heat distribution or volcanic activity, but we found no matching plume or impact. Some of those intervals line up within error bars, with oddities over the Indian Ocean region. Naima nodded. And then there are the softer facts. By soft, she meant evidence that was indirect, layered through human stories as much as through rock. Naima tapped the side of the shared hall. A second globe appeared, older and shallower. It showed coastlines and ice sheets shifting through the last few 100,000 years. Glacial advances, retreats, sea level rises and falls. Most of what we know about prehistoric cultures comes from coasts, she said. Lowland river valleys, places that flood when ice melts and seas rise. Each glacial cycle drowns a layer of history. We have learned to correct for that with undersea archaeology. Still, there are legends that do not fit our current data. Tales from Indian Ocean cultures about lands that sank, islands that were here before the ocean came. We have always linked those to post-glacial flooding or to simple invention. Now we find that under that same ocean sits an unnatural, structured mass. She shrugged. It may be coincidence, or not. A myth scholar, Dr. Kalpana Rao from the Pan-Indian Cultural Archive, joined in. In South India and Sri Lanka, she said, there have been stories for a long time about a lost land to the south. Kumari Kandam. In Tamil traditions, it was said to be a cradle of early culture that sank under the sea. 19th and 20th century colonials mixed that with Western fantasies and called it Lemuria. Of course, actual Lemuria, as they imagined it, never existed. Plate tectonics killed that idea 200 years ago. Continents do not just drop underwater, but if those stories contain even a twisted trace of something real, something else might have happened in the deep past. Maybe there was contact with those below. Maybe there were surface settlements that vanished for reasons we did not understand. And now people online are resurrecting every myth with the word Lemuria in it. Naima said dryly. They are connecting it straight to this structure. She highlighted the anomaly. Its outline glowed. For the sake of clarity, she said, and because the net has already decided, I propose we accept the name, at least as a working label. It is better than Indian Ocean Anomaly 34b. There was a brief murmur across channels. Names matter, said Kalpana. If you call it Lemuria, you tie it to stories of lost wisdom and hidden peoples. That can help or hurt how the public reacts. True, Naima said, but refusing the name will not stop people from using it. Better to define it properly. She looked toward Elion's window. Dr. Marek. Elion had been quiet, lost in the shapes inside the model. Yes, he said. Do you support using Lemuria as the label for the internal structure? Naima asked. Elion thought for a second. He had always disliked how myths were forced into science. Yet he also knew that technical designations like IO Inner Rig 1 would never catch on outside a small circle. We can formalize it, he said. Lemuria, the engineered mantle structure under the Indian Ocean. We state that the name comes from myth, but the thing itself does not confirm those old ideas. It is an object. How people fill it with meaning is another task. Naima smiled slightly. Spoken like someone who would prefer numbers. That is correct, Elion said. Then we have a term, Naima said. Lemuria, the mantle structure. Next question, when did it form? How long has it been there? Can we constrain its age? She nodded to Dr. Tsai. Tsai zoomed time sliders on the globe. The plates rolled backwards. India slid along an arc. Africa drifted. Madagascar scissored away from the mainland. We can track subducted slabs in tomography down to the lower mantle, Tsai said. They show up as colder, denser patches. By matching their position with known trench histories, we can date where they sank. Lemuria sits between several of these old slabs. None of them seem to cut through it. They bend around. She pointed with her stylus, tracing curves. This suggests Lemuria existed before those subduction events. That takes us back at least 250 million years, possibly more. Maybe to the early Permian. There are hints it might predate Pangaea's breakup, but the resolution gets worse beyond that. So we are talking about something that has persisted through multiple supercontinent cycles, Naima said, while the surface changed from giant reptiles to mammals to us. Unless it was modified over time, Taysed said. We do not know if the internal structure froze in place early, or was updated. And biology? Asked an astrobiologist from the Pacific, Dr. Satoshi Morita. Do we have any sign that Lemuria is or was alive, in any sense? Elion zoomed into the grid again. He wished he could do more than stare. Not directly, he said. We only see density, rigidity, some thermal patterns. But we can look for signs of heat management. Waste heat from organized processes would have to go somewhere. He had already run some quick checks. He called up those maps now. Under the Indian Ocean, in the region above Lemuria, the mantle appeared slightly cooler than expected in some layers, slightly warmer in others. Temperature distribution is odd, he said. There are cooler shells above and below high-density cores. It looks like something balanced heat flow deliberately. Natural processes can do that too, Tsai said. Phase transitions in lower mantle minerals, like perovskite and post-perovskite, can absorb or release heat in sharp layers. Yes, Elion said. But then the phase boundaries should follow pressure levels which roughly match depth. These shells are tilted. Their angles line up with Lemuria's boundaries, not with gravity equipotentials. That is worrying, Satoshi said softly. That looks like planetary engineering more than geology. Naima raised a hand. Let us not jump to motives, she said. First, answer the physical. Could any known form of life survive where Lemuria sits? Satoshi brought up a diagram of pressure and temperature versus depth. Lemuria's top is around 1,700 kilometers down, he said. The bottom at about 2,200. Temperatures there are around 3,000 to 3,500 Kelvin. Pressures 80 to 100 gigapascals. That is around 1,000,000 times surface air pressure. He switched to images. Deep-sea worms near hydrothermal vents, pressure-adapted bacteria from ocean trenches, then lattice diagrams of high-pressure minerals. Nothing we know on the surface could tolerate that environment, he said. Not as we are built, but life is a process, not a fixed form. If someone had millions of years and access to early Earth's chemistry, they could drive evolution or design directly for that niche. Think of organisms whose structural materials are not water-filled proteins and lipids, but high-pressure ceramics, silicon-based structures, metallic frameworks with quantum defects carrying information. Think very slow metabolisms, matched to mantle convection timescales. A heartbeat every hour, a breath every week. Time runs differently when your chemistry is slow. Kalpana gave a small shiver. Stories always talked about stone people or fire spirits in the deep earth, she said. We laughed at that. But something like this, life that uses rock as both body and environment. Again, Naima said, we must separate images from facts. We do not yet know if Lemuria housed any biological system. It could be an automated machine, a storage vault, a failed project. We do, however, know that it is active now in some fashion. Elion remembered the gentle rotation vector, barely measured yet clear. Was it always meant to wake? Sarah asked. Or did we trip some safety? On the wall, Irina Volkov raised a hand. If we want to answer that, Irina said, we must look at past climate shocks. She called up a new set of plots. Temperatures over the last few million years, CO2 levels, volcanic aerosols, ocean circulation changes. You all know about the big ones, she said. The Paleocene-Eocene thermal maximum, the end Permian event, Chicxulub and dinosaur extinction. But recent work has also found smaller, shorter anomalies, warmings or coolings that do not line up with known orbital cycles or volcanic events. Some of those blips cluster around times when the Indian Ocean basin changed in strange ways. Rapid shifts in mid-ocean ridge activity, faults going quiet for longer than expected, then releasing energy in smooth pulses rather than sharp quakes. She circled 3 shaded rectangles on the timeline. Here, here, and here. Each event lasted a few thousand years. Not long in geology, quite long for climate. Each shows signs of controlled degassing and uptakes of greenhouse gases, as if something was regulating. And each follows a period of major solar disturbance. Elion leaned forward. Solar disturbance. Irina nodded. We have good models of the sun's past activity from isotope records and star analogues. Every so often it throws big fits. Massive flares, coronal mass ejections much harsher than anything in recorded human history. One such event about 2 million years ago left strong traces in beryllium-10 and carbon-14. Another, less strong, around 600,000 years ago, and an older cluster around 900,000 years back. All 3 line up, again within wide error bars, with these odd climate regulation episodes. Satoshi's eyes widened. You are saying, he said, that when the sun went wild, something on or in Earth responded in a way that smoothed the impact. Irina spread her hands. It might be chance, Statistics can be cruel, but if you assume Lemuria is ancient and able to affect mantle outgassing, you can draw a line: large solar events stressing the surface biosphere or atmosphere, followed by subtle mantle adjustments that manage CO2 or volcanic aerosols. That implies awareness, Sarah said, or at least an automated response tuned for life at the surface, or tuned for life below, Satoshi said. Maybe surface stabilization is a side effect of some deeper need. Either way, she said, it suggests Lemuria's systems already interacted with planetary-scale cycles before humans appeared. If that is true, then the current activation might be part of a very long plan. Elion swallowed. If someone built that, he said, then they probably saw the future, or at least many possible futures. They might have planned to wait out dangerous zones of solar behavior, then return when things calmed. A long sleep through bad space weather. Kalpana nodded slowly. Like the myths of people who go into caves for an age and come back when the world is safe, she said. But here, the cave is the mantle. The sleep is measured in hundreds of thousands of years. Let us be specific, Naima said. What could drive a whole technological species to sink its home continent into the mantle? She ticked off options on her fingers. Global war? Maybe. Runaway climate disaster? Possibly. Asteroid impact? We know most of those. None in the last 50 million years were big enough. That leaves solar catastrophe as an interesting factor. A flare strong enough to strip atmosphere, kill surface life, or at least damage any exposed technology. Satoshi nodded. We see such super flares on other sun-like stars, rare but real. If Lemuria's builders were watching the sun closely, they might have predicted an active phase that would last tens or hundreds of thousands of years. They might have decided that going deep was safer than building shields in space. Could they not have gone to other planets? Someone asked. Maybe they were limited in interplanetary reach, Satoshi said. Maybe they had strong ties to Earth's chemistry, or to gravity and field conditions here. Mantle depths offer constant temperature, stable shielding from radiation, and near-limitless material, if you can solve the engineering. If, Naima repeated. They all turned back to the model. How did someone solve living in the mantle? Elion tried to imagine the steps, from more familiar extremes to this. First, deep oceans. Pressures of hundreds of atmospheres. Dark, cold, but still fluid water. Then deeper into the crust, boreholes, magma chambers lined with ceramics. Finally, into the upper mantle, where rock behaved like slow taffy over long times, but on human scales still felt rigid. Long that road, a species might branch. Some stay up top, others go down. The deep branch might change, physically and mentally, to fit that world. Stronger materials, slower thoughts, longer plans. He spoke without quite realizing. We are guessing about minds and bodies we have never seen, he said. But we can see their tools. Lemuria shows careful load paths. It balances itself in mantle flow. It shapes heat. It has external locks linked to the magnetic field. He called up a side model he had been working on. Watch this, he said. The globe shifted to show magnetic field lines threading through Earth from core to space. The main dipole south and north. Smaller loops, drifts. At Lemuria's depth, field lines were messy, but not random. When he animated their long-term drift, something interesting appeared. The points where key field lines cut the structure's surface moved, but they traced out repeating tracks. It looks like Lemuria's outer shells include high-conductivity materials, Elion said. They interact with the core field. Over millions of years, the system might use that interaction as a timing mechanism, like a clock based on field reversals, or on the slow change in multiple moments. Sarah frowned. So solar cycles and magnetic cycles as inputs. That fits the idea of planned long-term sleep and timed waking. Think of a lock with many tumblers, Elion said. Some linked to solar proton flux, some to geomagnetic tilt, some to mantle temperature at certain depths. The system naps while the pattern is not right. When all conditions match a safety window, it starts to wake. And we, Sarah said, have just added new variables. Naima nodded. Deep fusion mining. Artificial shifts in heat flow, changes in surface mass distribution from ice movement and dam projects, all noise on top of a delicate long-period signal. It might not be noise, Elion said quietly. It might be a trigger that tells Lemuria something new is on the surface, something that uses fusion in its crust, something that might be a threat or a partner. Kalpana's face grew still. If Lemuria's builders remembered early primates, she said, and then went under, they might have assumed that any later tool users would stay simple. Maybe scattered hominids with fire and stone. They could plan to return to a mostly empty surface as long as they slept long enough. They miscalculated, Naima said. Or they did not account for how fast a certain bipedal species could change. So when their long-timed wake-up approaches, Sarah said, they look up through rock, through neutrino sensors, whatever they have, and see us. See fusion plants, Satoshi added. Orbital grids, global networks, signs that the simple surface fauna did not stay simple. And then they adjust their plan, Elion said. The thought sat in him like a weight. Later, in a quieter breakout session focused only on Lemuria's internal design, Elion joined a smaller circle of structural engineers and materials analysts. They had pulled more from the deep penetration data in the last day, where before the object had been a blur, now it showed layers. The outermost shell was denser and stiffer than known mantle minerals. It had a thickness of tens of kilometers. Under that, patchy regions of lower density, arranged in repeating slabs. Deeper, a core of very stiff material, perhaps metallic, elongated along the structure's long axis. It is like a pressure vessel inside a pressure vessel, said Dr. Jana Ose, a structural engineer who had once designed deep ocean habitats, with support ribs that align along principal stress directions. And see these spikes? Added Dr. Wong, highlighting narrow columns that reached out from the main body into surrounding mantle. They might be anchors, or heat exchangers, or both. They seem to end near natural phase boundaries. That would let the structure bleed or take up latent heat by shifting material phases around those points. Elion highlighted a group of thin, repeating cavities along the inner shell. These could be stasis chambers, he suggested, or bays for something. They have similar dimensions, arranged with high regularity. Whatever they held, the designers wanted identical conditions in each. What about materials? Jana asked. Elastodynamic inversions suggest higher modulus than bridgmanite, Wong said. That is our standard lower mantle mineral. It is also denser by a few percent. Could be an engineered phase mantle silicate with impurities and defects tuned for strength, or some exotic carbon-nitrogen structure only stable at high pressure. Could it be metallic? Jana asked. Not pure metal, Wong said. The seismic velocities do not match iron or nickel, but the core might have metallic components. We see hints of high conductivity in how it distorts magnetic models. Bio-based? Someone asked. Elion shook his head. If there was biology, it is probably embedded in or supported by these materials, not made of simple organics itself. Standard carbon polymers would char or break down at these temperatures unless heavily protected, unless their biological tissue uses mantle phases, Satoshi's voice said from the link. Information stored in crystal defects, signaling via phonons instead of ions and neurotransmitters. You think like a science fiction writer, Jana said. Yes, Satoshi said. But so did whoever built this, before it was real. They continued passing features, broad chambers that might hold fluids under pressure, channels that looked like conduits for shared resources, web-like bracing that kept stresses from concentrating. Little by little, Lemuria became less of a blur and more of a design. With each new detail, the sense of a mind, a planning intelligence that had thought about rocks and heat and time on inhuman scales, grew stronger. At some point, someone joked about mantle giants and another about stone angels. The jokes did not last. The more they saw, the less energy they had for fantasy. The first real sign that Lemuria had not slept through the last few million years arrived in a form Elion did not expect. A pattern in fossil records. He was watching a filtered neutrino time series when Naima pinged him. Come to the paleobiology node, she said. You should see this. He linked in. The view shifted to a different wing of the virtual hall. Here, the central model was not Earth's interior, but a dense timeline of life. Silhouettes of species, branches of evolution, extinction spikes. Dr. Amir Jalal, a paleobiologist, waved him closer. We have been matching global extinction events and radiations against known external drivers, impacts, volcanism, orbital cycles, Amir said. Most match, as expected, but there are smaller regional events in the Indian Ocean basin that have always felt odd. He highlighted several bands. Between 1.1 and 0.9 million years ago, for example, we see a quiet die-off of certain deep-sea species in and around the central Indian basin. Not catastrophic, but selective. Some foraminifera lineages vanish. Certain benthic creatures disappear. Yet similar species in the Pacific and Atlantic survive. Environmental shift? Elion asked. Maybe, Amir said. But we see no sign of massive new sediment flows. No clear sign of large, sudden temperature swings that would hit that region harder than others. Then, 50,000 years later, we see a burst of new forms in that same area. Novel deep-sea species with odd mineralization in their shells. They appear there first, then spread outward. Currents alone cannot fully explain that pattern, he said. Something in that basin became briefly inhospitable to some life, then strangely rich for new experiments. And you think Lemuria did something from below, Elion said. Amir shrugged. We cannot prove it, but if Lemuria has been slowly testing the crust and boundary layers for eons, it may have sometimes stressed local habitats. It could have altered temperature gradients, seep-deep sourced chemicals, even leaked trace radiation or fields that affected certain organisms. To us, those show up as small blips in the fossil record. To them, it might have been routine maintenance. You make it sound casual, Elion said. Amir smiled sadly. If your baseline timescale is 1,000,000 years, a 1,000-year experiment is casual. The leak of the Lemuria maps hit the public harder than any of them had predicted. For a few days, the world's feeds turned into a festival of diagrams, simulations, and wild theories. Some artists turned the deep structure into glowing palaces, others drew it as a sleeping dragon, bones wrapped in molten rock. Religions responded in different ways. Some groups called Lemuria a test from their gods. Others said it confirmed their stories of hidden realms. A few denial movements insisted it was a government hoax designed to control fusion mining. More serious voices held official briefings. Planetary councils put out calm statements. No immediate danger, centuries until any possible direct crust interaction. Ongoing monitoring. International cooperation. Elion watched those sessions between data runs. When journalists asked who first recognized Lemuria's motion, some feeds showed a brief clip of him in Confront Sphere 3, pointing at an arrow. He did not enjoy the attention. He turned off most alerts, but he could not ignore the invitation that came from the Global Knowledge Commons. The Commons was a loose alliance of open data groups and academic networks. They held forums when something large happened. This time they wanted experts to discuss pre-human technological species, possibilities and responsibilities. Elion tried to say no. Naima called him directly. They trust you, she said. You speak in complete sentences. You do not dramatize. That matters now. Elion, Sarah added from another window. If you do not go, others will. People who like drama more than accuracy. At least show them how careful we have to be with each claim. He sighed. Fine, he said. But I will talk about data, not legend. Talk about both, Kalpana said from a third window. Legends will form regardless. Better to give them some grounding. The Commons Forum took place in a shared virtual amphitheater. Tens of thousands watched as avatars of experts took the stage. Elion's avatar looked like himself, only a bit less tired. The system had smoothed his wrinkles and dimmed his eyeshadows. He hated it. Naima spoke first, laying out Lemuria's known properties in simple diagrams. Then Kalpana summarized the human stories that had clustered around the Indian Ocean for centuries. At last, it was Elion's turn to answer the direct question that hung over the event. Does Lemuria prove that humans are not the first technological species on Earth? Asked the moderator, a journalist from the Pan-African Infonet. Elion let the question sit for a heartbeat. It proves that something built a continent-sized, highly structured object inside the mantle, he said. That object shows signs of active control and long-term planning. Our best models say it has existed for hundreds of millions of years. So yes, if we define technological species as a group capable of large-scale engineering, then Lemuria is strong evidence for a pre-human technological civilization. Do we know anything about who they were? The moderator asked. Very little, Elion said. We know they understood deep Earth physics and materials far beyond our current levels. They could shape mantle flow and magnetic fields. They could design for durations that span many of our species' lifetimes. We can guess they were once surface or near-surface living, because they built something to return toward the surface. If all they wanted was a permanent deep refuge, they could have sunk smaller, distributed units and stayed hidden forever. Instead, Lemuria's whole shape and motion suggest it is meant to come back into contact with the crust at some point. So you think they plan to re-emerge? I think that was part of the design, Elion said. We do not yet know why. A member of the audience raised a flag for a more pointed question. Some people are saying these beings might be our ancestors, she said. That humans are descended from them somehow. Is there any support for that? No, Elion said simply. Our genetic record shows a clear line of descent from earlier primates. There is no sign of a sudden insertion of a completely different genome in the last 1,000,000 years. If Lemurians existed as a separate intelligent species, they are not human in any normal sense. But that does not mean we are unrelated. All life on Earth shares some base chemistry. Lemurians, if that is what we call their builders, would have evolved from earlier life too, or at least used similar elements. Could they have modified us? Another asked. Shaped our evolution while they slept? Kalpana answered this time. We have endless stories about first people shaped by gods or elder races, she said. We must be honest. There is no strong evidence that our evolution was directed by external, intelligent design in that way. Human traits look like what you would expect from normal selection in changing environments. To claim Lemurians made us would be a new myth, layered on old ones without data. But they may have shaped the environment that shaped us, Irina added from the side. By smoothing solar shocks and climate swings, they might have made Earth more stable for long stretches. That could have allowed complex life, including primates and then humans, to flourish. In that indirect sense, if they acted to protect the biosphere, then all modern life owes them something. Elion felt an odd discomfort at the word owe. Humans already struggled to agree on what they owed each other. Adding an ancient deep species to that moral calculus made his head hurt. Yet he also could not deny the logic. If Lemuria's activation cycle was set long before humans learned to speak, he said, then we grew up on a world whose deep interior had a plan we did not know about. Whatever that plan was, we are now part of it, whether they meant that or not. The moderator nodded. Then the last question for this session, she said. We have heard that there may have been early signals, patterns in mantle vibrations and neutrino flux before deep penetration. Can you speak about that? Elion hesitated briefly, then decided there was no point in hiding it. We have found hints, he said. Subtle modulations in neutrino background that do not match our sources, seismic noise in deep records that looks slightly more regular than random. Nothing clear enough to translate yet, but enough to say that Lemuria is not just passive rock. We are working on ways to respond. You mean to talk to them? The moderator asked. To try, Elion said. Carefully. We are building patterns into neutrino beams that pass through Lemuria. Simple sequences, prime numbers, geometric progressions, the same basic tricks people proposed for interstellar SETI centuries ago. We are also testing controlled microquakes, tiny stress releases near safe faults that form patterns. If Lemuria senses strain in the mantle, it might notice those as out-of-place regularities. And if they answer, someone asked, half fear, half hope. Elion thought of the grids and shells deep below, built for immense pressure, immense time. Then, he said quietly, we will have proof that not only did a pre-human technological civilization exist, but some part of it endures enough today to notice and respond. That will change how we see everything. He did not add. It may also force humanity to decide quickly what it wants to say in return. Back in the lab on the orbital station, the real work of listening began. Elion leaned over a bank of displays, watching long streams of numbers scroll past. Most people would have seen only chaos. To him, the noise had shapes. The station AI, now running in a dedicated high-attention mode, spoke. Neutrino beam NB7 passing through Lemuria volume. Modulation pattern primes up to 101 repeated 3 times. Signal strength nominal. Detector array? Elion asked. Array A India, receiving with expected attenuation and scatter. Array B Australia, same. No anomalous sideband structure yet. They had been sending simple patterns for hours now, in short bursts separated by long quiet intervals. It may take them years to respond, Sarah had said earlier. If their basic processes run slow, well, they might not respond at all, Elion had said. If their priority is caution. He thought about that now while the beams pulsed. If you were deep and powerful and old, he said to the AI, and you saw a new frantic species fill the surface above your sleeping place, would you answer a signal from them, or stay silent until you knew more about their behavior? Unknown, the AI said. I lack an evolved survival instinct, and cannot model their values. At least you are honest, Elion said. He switched views to a different feed, recordings from seismic stations around the Indian Ocean. Earthquakes did not stop while people watched deeper things. Plates still moved, faults still slipped, the seafloor still stretched and cracked. Most of these events were natural, yet, here and there, the AI had flagged small tremors with focal patterns that did not quite match ordinary tectonics. Very small strains spread over surprisingly large areas, as if someone was practicing how to push without breaking. We will call those training motions, Sarah had said. Elion watched one of them now. A slight adjustment under the central basin spread across hundreds of kilometers, raising the seafloor by less than a centimeter. Those changes, placed over enough time, could add up to major uplift. He thought again of the long plan. If Lemuria is on a scheduled rise, he said softly, then all of this, our signals, their adjustments, is part of the same story. They intend to come up. We happen to be here. The AI did not reply. On another panel, Irina's latest solar forecasts ran. The next few 100,000 years looked calm compared to the spikes of the distant past. No expected superflares of the same scale. If they built falls and rises around solar cycles, he murmured, then from their old view, this is as safe a window as they will see. Safe for them, not necessarily simple for humans. His mind kept returning to a deep, unsettling question. Had they ever considered that someone else might already occupy the surface when they came back? If they did, how had they imagined that encounter? Had they hoped for students, prey, partners, or had they assumed that any surface species would be small enough to move aside? He did not like any of those options. He liked even less the thought that they had never imagined a second technological species at all. 2 days later, the first answer arrived. It did not look like an answer at first. It looked like noise. Elion and the AI were reviewing beam records when a faint, regular variation appeared in the neutrino counts from one detector. Local calibration glitch? Elion asked. Unlikely, the AI said. Pattern seen in 3 independent detectors at different depths. Periodic modulation at 0.1 Hz. Slight phase shift between beams passing through Lemuria and control beams that graze it. Elion froze. Show different signal, he said. A new graph appeared. Against a background of random scatter sat a very faint, very regular up and down pattern, as if someone far away was tapping gently on a wall. Run all known sources, he said. Fusion plants, cosmic ray showers, calibration pulses, anything that might cause this. The AI did so. One by one, known influences were subtracted. The pattern remained. It could be internal noise in Lemuria, Sarah said when she saw it. Not communication, just some cycle. It might be, Elion said, but look at the timing. He overlaid their outgoing prime number sequence on top of the faint oscillation. The first few pulses from below lagged by a random amount. Then slowly their rhythm shifted. Not to match the primes, but to avoid them. The deep signal began to fall into gaps between outgoing bursts, like someone talking in pauses between words. It is aware of the beams, Elion said quietly. Whatever is producing that variation can sense our signals enough to shift around them. His skin prickled. That means we are not only looking at dead, ancient engineering, Sarah said beside him. Something down there is awake enough to react in real time. Maybe not fast by our standards, but real. Elion stared at the gentle 0.1 Hz wiggle. In that case, he said, voice low, we have just had our first conversation with a non-human technological system that started millions of years before us. He exhaled. And we do not even have a translation yet. Behind the graphs and numbers hidden in stone and heat, Lemuria held its secrets. But now the secrets were not completely silent. They had nudged a signal, shifted a pattern, made their presence known. The memory of stone, long buried and long patient, was stirring. Humanity had asked a question with beams and small quakes. Earth had answered from its depths in a slow, faint pulse. It would take time to understand the language, time to reconstruct lives and minds that had chosen to hide inside a planet, time that both species might not have, if their needs for space and stability could not fit on the same world. For now, though, Elion allowed himself a rare, still moment of awe. Not fear, not theory, just simple recognition. We are not alone, he said quietly to the AI, to himself, to the image of the globe. Not in the universe, maybe, but for sure, not even on our own planet. The first sign came as a number that refused to fit. Elion sat in the orbital lab with his hands wrapped around a cup of thick station coffee, staring at a live map of global strain fields. Thin arrows covered the world, each arrow showing how small blocks of crust were stretching or squeezing. He had looked at maps like this for years. This morning, something felt off before he could say why. Switch to anomaly view, he said. The AI dimmed all arrows that matched standard plate tectonic models and brightened the rest. Around the Pacific Ring of Fire, only a few arrows glowed. That was normal. Models there were already good. Under the Indian Ocean, a wide belt lit up like a bruise. Scale, Elion said. The AI zoomed in. The central basin swelled in his view. The glow spread along mid-ocean ridges, then curved in a smooth loop toward East Africa and Western Australia. The arrows inside that glow were small, but they pointed in directions that should not exist. They showed the seafloor rising and falling in a broad, gentle pattern, not tied to known ridge push or slab pull. It looked almost like someone was pushing up from below with a huge, soft hand, careful not to snap the crust. Elion? Sarah drifted into the doorway, a hand on the frame. Her hair was still damp from the hygiene block. He gestured at the map. Indian, he said. She frowned, pulled herself closer, and called for the same view on her side. Is that new? She asked. Last 12 hours, Elion said. It grew fast. Sarah chewed her lip. Could be just a rare fluctuation. Showtime series, Elion said. The AI spun a slider backward. The glowing belt shrank. 12 hours ago it had been a thin, faint curve. A day before that, almost nothing. Whatever it is, Sarah said, it is accelerating. Compare with Lemuria's predicted stress field, Elion said. The AI overlaid a transparent shape on the map, showing Lemuria's projected footprint at depth. The glowing crust anomaly sat almost exactly above the central portions. It is trying to adjust the lithosphere, Elion said softly. Not just itself. Sarah's eyes narrowed. Gentle, she said. Like you said in the council, careful motions to avoid catastrophic quakes. Until they cannot avoid them anymore, Elion said. If they keep going. He took a slow breath. Log this as priority A anomaly, he said to the AI. Send to IODET and global quake nets. Done, the AI said. Outside the station, the blue disk of Earth turned on. Far below, waves crossed the Indian Ocean as they had every day for ages. Yet under that water, deep rock was beginning to shift in a pattern that had never been seen before. In the days that followed, the world started to feel a new kind of nervous. Not sudden panic, more like the way people glance at the sky every few minutes when forecasts warn of a storm. Seismic monitoring centers shared more data. AI clusters around the planet compared every tremor, every minor quake, to long-term patterns. Most quakes behaved as usual. A few did not. Small magnitude 4 and 5 events under the Indian basin had strange focal mechanisms. Instead of sharp slips on clear plains, they looked like spread-out, low-angle stress releases. This is what it looks like when something uses the crust like a flexible sheet, Sarah said during a call, pushing here, easing there, trying not to tear it. On the orbital lab screens, Elion could see the effect when he ran stress simulations. Where Lemuria's upper surface came closest to the lithosphere, force lines bent away, softened, spread. If they are this cautious, he said, they must know how fragile the surface biosphere is, or they do not want to damage the crust they plan to live under. Or both, Sarah said. News feeds picked up the changes. They ran simple animations, a rising shape under the Indian Ocean, plates flexing above it. Some feeds pointed to increased microquakes on certain coasts and made them sound worse than they were. Others tried to calm viewers. Global councils sent clear messages. There is no sign of a global quake disaster. We see controlled, slow motions. The risk of sudden megaquakes has not increased yet. Alongside these reports, a different kind of story spread. People wanted to see. Citizen groups began building and launching small ocean probes, cheap, smart buoys and drones that could sail or dive toward the anomaly zone. Some were funded by universities, some by open-source collectives, some by private donors who liked the idea of being part of first contact with Earth's other civilization. At first, authorities tried to limit them. Too dangerous, said an Indian Ocean Regional Council statement. Waters above the anomaly may experience unusual currents. We need controlled missions. With 25th century materials and print-on-demand fabrication, a high school class could put together a pressure-rated sensor pod from open designs and launch it off a rented boat. Names began to appear in trending lists: Sea Route 3, Deep Lens, Freedive Lem 1. Each pod carried a set of instruments: cameras, sonar, magnetometers, temperature sensors, simple neutrino detectors, sensitive to high-level pulses, and basic acoustic transceivers. Most could not reach more than a few kilometers down, nowhere near the mantle. But they could map the seafloor and water column above Lemuria in finer detail than many official surveys ever had. Humans will not sit still, Sarah said during a late call with Elion, watching a live map of citizen probes cluster like insects over the central basin. They see a line on a map and think field trip, Elion replied. You sound fond, she said. Concerned, he said. Fond after that. Official missions were not standing still either. The Global Deep Ocean Collective, a group of states, institutes, and oceanic city governments, launched a fleet of high-end research submersibles and autonomous landers toward carefully chosen points above Lemuria. The avatars of those craft showed up as larger, labeled icons on Elion's map. Odetis Indi 1, a heavy autonomous crawler, was the first to reach its target. It dropped from a support ship, sank through sunlit waters, then deeper blue, then darkness. Its progress showed as a depth graph on Elion's screen, climbing down past 1,000 meters, then 3,000, then 5,000. Seafloor contact, the mission AI announced to all subscribers. The crawler's cameras switched on. Monitors across labs and homes filled with grainy images of black mud, scattered basalt, small white crabs and strange worms peeking from burrows. It rolled forward in careful steps. Its sonar scanned the ridge ahead. Nothing strange appeared at first. The crust here was as expected, mid-ocean ridge basalt with thin sediments. The anomaly lay much deeper. Still, ODS Indy-1 seismometers felt the long, slow pulses from below, a regular, almost wave-like pattern in stress that rode on top of normal plate motion. "It is like standing on a chest and feeling someone breathe," said Dr. Wong. A smaller, more agile robot, named Pelagia 7, dove free in open water above. At 3,800 meters, its cameras picked up an odd sight, a tight spiral of sperm whales, circling around a point in mid-water, singing in a complex pattern. "Is that normal?" Elion asked Satoshi, who had joined the watch. "No," Satoshi said. "Whales sometimes spiral when feeding, but this is too deep for their usual prey, and the pattern of their clicks is strange." He overlaid whale song spectrograms from other parts of the ocean. "These calls have repeated elements that line up with the rhythm of the deep stress pulses," Satoshi said. "I think they are reacting to something they feel through their bodies. Tiny pressure changes in the water from the crust flexing. Using whales as accidental sensors," Sarah said. "Lemuria pushes. Whales sing about it. We listen to the whales. It would have been funny if it was not so eerie. Other species were acting strange too. Deep-sea fish that usually spread across wide areas now clustered more tightly over certain parts of the basin. Bioluminescent plankton showed odd flashing patterns in some regions, as if responding to faint electrical or mechanical cues. It is like someone is tapping on the underside of the ocean," Satoshi said. "And the animals know even if they do not know what it means." The first time a deep-sea probe vanished, people blamed hardware. Freedive Lem-1 was a volunteer-built glider launched from a small Indonesian port city. Its makers streamed the whole process, the final checks, the drop from the boat, the slow sink. The probe reported depth and simple sensor data every minute. Temperature, salinity, pressure, background noise. At 2,000 meters, all was normal. At 3,600, pressure rose, light dropped to near zero, and the unit switched to its low-power profile. At 4,100, it sent an excited message. Temperature rise anomaly plus 0.5 K over model. Comments scrolled under the stream. At 4,200, its last packet arrived. Then nothing. No sign of a hull breach. No distorted signal. Just a clean stop. The support boat crew waited for the emergency ascent ping that should have triggered if the probe systems detected anything grossly wrong. It never came. Could be a short, one of the Freedive engineers said live, or a software crash. Skeptics nodded. Cheap equipment fails. The second disappearance was harder to shrug off. ODS Indy-2, a professional-grade crawler, approached a small trench on the seafloor above a spot where Lemuria's upper shell came closest. Its cameras showed a gentle slope of fine sediment, then an abrupt drop. Lowering, the mission AI said. Descent path clear. It crept down. At 5,400 meters, video showed darker rock coated in thin mud. At 5,421, all streams video, sonar, seismic, telemetry cut out mid-frame. Backups did not come online. The tether, a fiber optic line up to the support vessel, remained intact. Physical tension sensors reported nothing more than the weight of the cable. "Retrieve," the chief operator ordered. The winch spun. The cable came up. The end was clean and dry. The mechanical connector was still in place. The probe was not. "That is impossible," someone said in the mission room. Later, forensics showed no sign of mechanical cutting or burning on the connector. No unusual strain. It was as if the mass attached to the end of the cable had simply been removed. Freedive Lem-2, another citizen probe, vanished 3 days later in a different sector, again with no clear sign of failure. Loon stared at the incident maps. "Show probe loss locations against Lemuria projection," he said. The AI overlaid the points. They all sat over regions where stress simulations predicted thin zones in Lemuria's upper shell, possible windows or conduits. "They are not random accidents," Sarah said. "Someone down there is testing everything that approaches. Testing or defending," Naima said in a later meeting. "Taking apart anything that gets too close. Or sampling," Satoshi said. "Collecting information. Our probes might be like bits of drifting plankton to them. Curious little machines that taste of metal and signal." "Either way," Elion said, "we have to assume that any device we send near those zones will be noticed and may be taken. We cannot rely on simple presence anymore. We must treat approach like contact." Global councils issued new guidelines. Official probes would mark themselves with standard neutrino pulses and acoustic signatures, a kind of "I am not a stray rock" tag. Volunteer groups were urged to do the same. Some listened, others liked the idea of being invisible. As days turned to weeks, Lemuria's slow influence on the crust became clearer. Under the central Indian basin, GPS beacons on undersea ridges and islands showed tiny, steady rises and tilts, a few millimeters here, a centimeter there. Nothing dramatic, but the pattern was too smooth and wide to be explained by normal ridge spread or post-glacial rebound. In East Africa, some deep wells registered slight changes in water levels, not linked to rain or extraction. In Western Australia, certain ancient rock formations experienced strange, gentle stress shifts. The net filled with maps and plots. Journalists started using phrases like the slow uprising and Earth's second continent waking. Elion disliked those terms because they implied attack, yet he had to admit they had a kind of truth. Lemuria was rising, very slowly. Its motions were careful, almost kind, but they were also relentless. One night station time, though night meant very little in orbit. Elion sat alone in the lab, staring at a single graph, the faint 0.1 Hz modulation that they had taken as Lemuria's first true answer weeks earlier. The pattern had continued. It changed very gradually over time. At first it seemed to be just avoiding their outgoing pulses. Then, over days, it began to add tiny, higher frequency wiggles on top of the base rhythm. Elion and the AI had been running pattern tests on those wiggles. They did not match any simple sequence known from math or human languages. Not primes, not Fibonacci, not simple encodings. But they did show structure. They had repeating segments, clear boundaries, and variations in amplitude that stayed within set lines, almost like a limited alphabet. It is language, Sarah had said when they first saw that. Or at least code, or a very complicated machine cycle, Elion had replied. But yes, something more than random. Now a new result sat on his side screen. The AI had tried a different approach. Instead of matching the deep signal to numbers, it had compared it to the pattern of stress pulses under the Indian Ocean. The match was not perfect. Cross-correlation high at delays of 1.3 and 2.6 hours, the AI said softly into the quiet lab, as if not wanting to break something, suggesting the neutrino modulation and the slow stress changes are linked by some internal process lag. So they talk inside themselves in at least two ways, Elion said, by changing density and stress in their own body, and by modulating neutrinos they send or absorb. He rubbed his eyes. How do you design a civilization that uses mantle physics as part of its language? He asked. That question assumes their social structure resembles human civilizations, the AI said, which is not certain. I know, Elion said, but I lack better words. He looked back at the graph. We need help, he said. Options? The AI asked. Deeper pattern analysis. Multiple AIs. Maybe quantum correlation engines. And more importantly, more kinds of data. Signals from ocean, from crust, from animals. If Lemuria's influence shows up in many layers, we can see how their messages look in each. He pulled up a new workspace and began sending requests to different labs. Within hours, he had a small ad hoc project, the Lemurian Language Group. It included data scientists from Africa and Europe, animal behavior experts tracking whales and other deep creatures, seismic pattern analysts, old SETI veterans who had once listened to stars and now turned their tools inward. Some of them had spent decades waiting for a non-human signal. Most expected it to come from the sky. Now they were using their cross-correlation algorithms and anomaly detectors on the planet itself. It feels strange, said Dr. Hadia Mensah, a former radio SETI researcher, in the group's first call. We used to point dishes at stars and dream of greetings from far away. Now we point sensors down and look for the same thing in rock. At least the delay is shorter, someone joked. No years-long wait for a reply, only hours. If their basic cycle is that slow, Hadia said, it may still take days or weeks to complete a single sentence. We have to be patient. Elion nodded. We also have to be humble, he said. We are trying to read a language shaped by heat, pressure, and a brain or brains that think in volumes, not lines. We cannot assume they use the same tricks we use. They set up shared dashboards. One showed live neutrino modulation. Another, mantled stress maps. Another, filtered whale songs and other animal responses. Others held lab simulations of how a Lemurian signal might look if it had to pass through hundreds of kilometers of rock and water. Over time, faint patterns began to emerge. When the neutrino signal shifted to a certain sequence of amplitudes, deep stress pulses also changed rhythm, and certain whale groups altered their song patterns in matching ways. Triangulation, Hadia said. They are doing something that affects all three media. We can treat that as a single syllable or symbol, even if we do not yet know its meaning. Lukon long. Elion felt something like the early days of physics, when scientists had seen spectral lines from elements without knowing why they appeared where they did. Meaning could come later. First, they needed a dictionary of forms. Not everyone on Earth cared about careful decoding. Militaries wanted to know if Lemuria could cause quakes under certain coasts. Energy councils wanted to know if it would block deep geothermal projects. Religious leaders wanted to know if this was a test. Ordinary people wanted to know if their cities would sink. Under pressure from many sides, the planetary councils pushed Iodete to answer the biggest question. Is Lemuria hostile? In an emergency session, Councillor Jian put it plainly. We need a public answer, even if it is just we do not know, she said. Keeping silent will make people invent worse stories. A lion patched in from orbit spoke carefully. We do not see signs of active attack, he said. Lemuria's crust motions are gentle compared to what it could probably do. It has not triggered large quakes or sudden uplifts. It has not tried to collapse any specific region. It has taken some of our probes, yes, but always at small scales and without sending destructive waves upward. What about the deep neutrino modulation? Jian asked. Could it be scanning us for weaknesses? It could, Elion said, but any advanced system would do that as part of basic awareness. We are scanning them as well. The key fact is that we have not seen clear efforts to use crust stress as a weapon against us so far. Yet, murmured Dr. Sai. Yet, Elion agreed. We have also not seen clear efforts to avoid all harm. If Lemuria continues to rise, some coastal zones will have to adjust. Sea levels will change unevenly. Old cities may become unstable. That will look like an attack to the people who live there, Jian said. I know, Elion said. Naima spoke next. We must also ask what their intent is toward the surface environment, she said. Past climate records suggest Lemuria's systems once smoothed solar shocks. That points to a concern for planetary stability, if not for our sake, then for theirs. But concern for stability does not mean concern for individual species or civilizations. They might be willing to let surface systems rearrange as long as the biosphere as a whole endures. So we are like grass on a construction site, a councillor from a coastal federation said. Some will get flattened, the field will still exist. That is one harsh way to put it, Naima said. I hope it is not accurate. We do not yet know how they rank different forms of life in their moral view. A quiet voice cut in from a small screen. It belonged to Kamal Suresh, a philosopher specialist on interspecies ethics. We are trying to read too much into too little, Kamal said. There is a danger here. We will project our own motives plain onto them. If we fear invasion, we will see aggression in every motion. If we hope for mentorship, we will see kindness in every restraint. Right now, the most honest statement is, Lemuria is adjusting the planet for its own needs according to a very long plan. Those adjustments affect us. We cannot yet call them hostile or friendly. We can only call them self-serving. That may be enough for now, Jian said. We will tell the world this. Lemuria is not trying to kill us. It is not trying especially to save us either. It is trying to live. And we, Kamal said, are trying to do the same. On the surface, life went on. People still went to work, raised children, watched entertainment feeds. But the idea that there is a second civilization in our planet colored many small acts. In some ocean cities, families gathered on balconies to watch the dark sea and talk in low voices about deep neighbors. In interior megacities, children pointed at cracked sidewalks or tiny tremors and asked, was that them? New art movements sprang up overnight. Mantle realism galleries that showed twisted sculptures based on Lemurian grids, neon tattoos of rising continents, songs that used slowed-down whale calls as bass lines. Some people wore Lemuria-themed jewelry, rings with black stones, necklaces with faintly glowing lines that followed the shape of the anomaly. In the orbital station's shared lounge, Elion overheard a pair of younger techs arguing. It is not our problem, one said. Centuries away. We can leave if it gets bad. Move to Mars or the belts. Not everyone can go, the other replied. Most of our infrastructure, our history is on Earth. Besides, do you really want to leave behind a planet with something like that waking up, without at least understanding it? As long as it does not smash my family's house, the first said. They can have their deep party. Long, feeling older than his years. Leaving Earth had become easier in the last century, but it was still costly. A few million could go, tens of billions could not, and even those who left might not escape the effects of a changed Earth. Altered climate, different resource flows, new gravitational fields affecting orbital dynamics. There was no clean divide. The next big shift in the slow uprising did not come from the deep. It came from the surface. A group of independent researchers, engineers, and activists, who called themselves the Open Mantle Initiative, announced a bold plan. They wanted to send a probe not just into the ocean above Lemuria, but into the crust itself, toward the top of the structure. "We have drilled 12 kilometers down before," their leader, Dr. Maya Rios, said in a widely shared video. "Old Soviet projects reached that far with crude tools. With modern fusion drills and nano-ceramic casing, we can go deeper, faster, and safer. We propose a controlled borehole on a stable plate segment in the central Indian basin, above a relatively thin section of crust. Our goal is not to pierce Lemuria, but to get within tens of kilometers, close enough to observe physical effects directly." Her team had gathered support from several ocean states and open tech foundations. They had designed a drill pod that would use a compact fusion reactor to heat and fracture rock, then vitrify the walls to prevent collapse. Official councils had not approved the plan. "We are still discussing," Jian said in a formal statement. But Rios's group had funding, equipment, and a leased platform ship from a sympathetic ocean city. They were not waiting. Elion watched their progress with mixed feelings. Part of him admired the courage. Part of him feared the risk. "If they get too close, Lemuria might react strongly," Sarah said in a private call. "It has tolerated our ocean probes as annoying fish. A drill could feel like a spear. We cannot stop all human curiosity," Elion said. "But we can argue for caution." They both signed on to an open letter urging the Open Mantle Initiative to limit depth, share all data in real time, and install strong emergency shut-off systems. Rios replied with a short message. "We hear you," she wrote. "We will keep margin, but waiting for slow committees while a once-in-history opportunity lies under our feet, that feels wrong too." Days before the planned drill launch, Lemuria made a move that no one could ignore. It sent a stronger neutrino pulse, not a gentle modulation, a spike. All neutrino detectors on the planet lit up at once, their logs flooding with counts 10 times higher than usual background. Screens in labs flashed warnings. Old software, designed only for solar flares and supernova alerts, woke with confused messages. Elion sat up so fast his chair drifted. "Source," he snapped. The station AI had already checked. "Direction, arising from within the planet," it said. "Angular distribution consistent with origin in Lemuria volume. Spectrum does not match standard fusion signatures. Pattern, single, sharp burst followed by decaying oscillations. It is like they shouted," Hadia Mensa said on the Lemurian language group channel. Then waited. Long over Earth, AIs and humans compared the pulse shape to every pattern they had sent down in the last weeks. The answer came back quickly. The burst's envelope matched, in reverse, the composite of human prime pulses, simple greetings, and other attempts. "They just sent our own hello back at us, inverted and amplified," Sarah said. "That cannot be an accident." "It is a classic response," Hadia said. "Mirror the signal to show you heard it, then send it strong enough that even a clumsy listener can tell." The timing also stood out. The pulse came exactly 12 hours after the Open Mantle Initiative announced the exact coordinates of their planned drill site. "Message?" Jian asked, in an urgent council call. Elion felt his mouth go dry. "I think they are saying," he said, "we hear you, we know where you are, we know what you are planning, and perhaps," Naima added, "they are saying, do not." "That is interpretation," Kamal said, "but we have to take the possibility seriously. If we dig toward them now, right after a clear sign of awareness, we risk showing aggression by their standards." Council votes ran fast. In the end, a majority decided to declare a temporary moratorium on new deep drilling in Lemuria's influence zone, official and private, until a clearer line of communication could be established. Enforcement was another matter. Some fusion corporations grumbled but agreed. They had wide interests and did not want to be blamed for starting a war with the interior of the planet. The Open Mantle Initiative was split. Part of the group argued to obey the moratorium. Another part, more radical, saw it as proof they were on the right track. "If something down there reacts this strongly to just an announcement," said a sharp-faced engineer in a leak from a private meeting, "that means we can poke it, and it cares. That is good. It means we are not irrelevant. A long. Elion listened to that recording with a cold feeling in his stomach. Feeling not irrelevant to a mantle civilization might not be a good thing. Amid all this, Lemuria's own slow work did not stop. New strain maps showed the soft uplift spreading. Gentle bulges in the crust appeared over months, raising some seafloor ridges by up to 2 centimeters. On many coasts, tides shifted by a few millimeters. Oceanic harbors noticed slight changes in echo sounder depths. Some ports had to recalibrate their docking software. In East Africa, a chain of small quakes, magnitude 3s and 4s, ran along parts of the Great Rift Valley. None caused major damage, but seismologists noticed something odd. The pattern suggested forces acting not just from the sides as plates pulled apart, but from below, as if the base of the crust was being stretched upward in certain spots. "It is like they are trying to line up future cracks with old weaknesses," Sarah said, tracing the quakes on a map. "That way, when they push harder in a century, the crust will break along known lines, not random ones." "Reducing surprise," Elion said. "Predictable faults are easier to live with. If your sense of easy covers 100 years, Sarah said dryly. He did a quick calculation in his head. "If Lemuria keeps this pace," he said, "the first major human infrastructure impacts might occur within a few decades. Sea walls built on tectonically quiet coasts might start leaning. Some ocean cities anchored in sediment might need new supports." "Enough time to adapt," Sarah said. "If we plan." "Enough time to adapt," Sarah said. "If we plan." Late in the chapter of these weeks, the Lemurian language group made a small breakthrough. It did not feel dramatic. It began with a young code analyst named Rafi Zolman, noticing that certain segments of the neutrino modulation repeated after big events. "There," Rafi said in the group channel, highlighting a cluster of wiggles around the time of Odious Indy 2's loss. "This pattern shows up every time one of our probes disappears." And here, he marked another instance, right after the big neutrino pulse we think was a mirror hello. Hadia overlaid several of those cases. The similarity was strong. "It could be a kind of label," she said. "A tag for events involving interaction with our machines." Satoshi chimed in from the biology wing. "We also see a similar shape in whale songs after certain stress pulses," he said. "When deep whales encounter unusual temperature shifts, they add a repeated click pattern at the end of their calls. Our AI thinks the Lemurian pattern may be structurally parallel. Hunjiabida. So maybe this is a word," Rafi said, excitement growing, "that they use for you or surface life or external agent." "Careful," Kamal said, who had joined the language calls as an ethics advisor. "We are at the stage where our minds will rush to hang meanings on patterns. Right now, all we can say is, they have a distinct symbol that often appears when they touch our tools." "Even that is big," Hadia said. "It means they categorize events. They have internal labels. That is true whether they are individuals, a hive, or one big system." Elion listened, feeling a strange mix of detachment and awe. He had spent his youth trying to map rock. Now in late middle age, he was watching the first attempts to map the thoughts of an alien mind inside that rock. "We need to talk back using their style," he said. "What do you mean?" Hadia asked. "We have been sending simple math," Elion said. "Primes, geometry. That is fine for basic we are intelligent evidence. But if they already know we are structured, if they have seen our technology for some time, then they might be more interested in knowing what we consider important. In their code, certain stress patterns may be basic grammar, certain neutrino sequences may be emphasis. We should try to build aligned patterns when something important happens on the surface. We encode a marker in our outgoing beams and in our controlled microquakes." "Like what?" Rafi asked. "Big events," Elion said. "Global cooperation moments, conflicts, major climate shifts. If they are watching the crust anyway, why not show them how we tag our own actions?" "That is risky," Kamal said. "We reveal our internal struggles. They probably see those already," Naima said. "Our wars and pollution have left deep marks, but explicit markers could show that we are self-aware about those actions, not just blindly crashing around." The group debated for hours. In the end, they agreed to run a small test. They chose an upcoming event, the planned shutdown of a large fusion mining operation in a seismically sensitive region, as a gesture of caution toward Lemuria. When the shutdown happened, seismic waves would send a clear signature through the crust. At the same time, they would send a distinct neutrino pattern they had not used before. A long, slow rise followed by a sharp drop, something that could stand out against noise. They would then watch how Lemuria's internal signals changed. "It is like teaching a child or an animal a new word," Satoshi said. "We show them a clear pairing, this loud surface act equals this deep code." Or, Kamal said, "It is like waving bright flags in front of a sleeping dragon. Let us hope it does not hate flags." On the day of the test, Elion sat in the lab again, coffee cold at his side, eyes on multiple screens. At 12 UTC, the fusion mining station in Central Asia began ramping down. For years it had drilled hot rock miles below a stable craton, pulling heat and rare elements. Its shutdown sequence had been planned for weeks. Gradual power bleed, coolant management, safe sealing. The crust above felt a slow change in stress as heat extraction ceased. Subtle ground-level sag stopped. Very small quakes rattled nearby monitors. At the same moment, orbiting neutrino beams began sending the special marker pattern through Earth, timed so most of it passed through Lemuria's volume. The Lemurian language group watched. For hours, nothing obvious changed. Then, about 5 hours after shutdown, one of the deep 0.1 Hz wiggles paused. A gap appeared in the otherwise regular mantle stress rhythm. Neutrino modulation flattened for a full cycle, then resumed with a slightly altered shape. It is as if they hesitated, Hadia said quietly. Took notice, maybe logged the event. Compare code before and after, Ruffy said. The AI began detailed analysis. A long. A day later, it returned a result. There is a new segment, it said. A cluster of modulation elements that did not appear in any archive before this test. It recurs twice in the last day. First, shortly after the fusion shutdown marker. Second, shortly after a planned microquake sequence we sent as an additional tag. They learnt the association fast, Hadia said. Or their systems are tuned to map new patterns quickly. What if that new segment is their version of a question? Satoshi asked. Or a warning, Kamal said. Elion stared at the compressed waveform. He saw only hills and valleys. His mind wanted to see meaning. It is contact, whatever else it is, he said. Not just a mirror this time. A change in their behavior based on our actions. The slow uprising is not only physical, Naima said. It is intellectual. Two ways of thinking starting to touch. Elion thought of the subtle uplift of the crust and the subtle uplift of signal patterns. Both were gentle. Both were easy to ignore day by day. Taken together, they were changing the shape of the world. That night, station night, Elion could not sleep. He floated in the dim common area, watching Earth spin below. The Indian Ocean lay in darkness at that moment, its surface a black sheet speckled with ship lights and the faint glow of some floating habitats. He imagined what lay under that dark water and thin crust, a continent of engineered rock, shells and cores and grids, slowly flexing. Somewhere inside it, processes ran that no human had ever seen. He thought of the whales spiraling above hot points, of missing probes, of faint pulses. He thought of human cities on coasts, full of people who had no say in mantle plans. AI, he said softly. Status on Lemuria's motion? Net uplift of upper boundary in last month, 3.2 millimeters under central basin, the AI said. Net rotation of structure, 0.003 degrees. Humans measure in millimeters and thousandths of degrees, Elion said. They measure in centuries. Yes, Elion said. Assumption. He watched the planet in silence for a while. Do you think, he asked the AI quietly, that Earth can really hold two global civilizations, each with its own view of what the planet should be? Insufficient data, the AI said. Outcome depends on many variables, including choices made by both systems. Cooperation, conflict, adaptation, departure. You did not include extinction in that list, Elion said. It seemed implied, the AI said. Elion almost laughed. He let himself drift, eyes closing for a moment. Below, unnoticed by most, the crust trembled in smooth, regulated patterns. Above, in labs and homes and ships, a fast, noisy species tried to understand a slow, quiet one. Between them lay rock. Rock that remembered more than any single mind, and that now carried two kinds of thought. The slow uprising was not a march, not a roar, but a long, careful adjustment from below and from above. The world was stretching to make room. Whether it would be enough room for both remained unclear. The first time a human city moved because of Lemuria, it happened so slowly that many residents did not notice until it was already underway. New Mombasa had been built on reinforced platforms along the East African coast, anchored into old bedrock and engineered with margin for sea level swings. For decades it had sat stable, a bright arc of towers looking out over the Indian Ocean. Now, those towers rose a little higher each year, not from new floors, but because the ground under them was lifting. Millimeter by millimeter, the crust under the city tilted inland as Lemuria's careful push under the basin flexed the plate. Engineers saw it first in laser surveys and gravimetric scans. Subsidence reversed, one report said. Foundations now rising at 3.4 millimeters per year. At first that seemed like a minor curiosity, a positive one even. Then, small cracks appeared in some older transport tunnels. Docking levels had to be recalibrated every month. Drainage systems began to behave in unexpected ways. You can live with a few millimeters, the city's chief engineer told the council. But if uplift accelerates, we will need to rebase parts of the city on adaptive floaters or deepen anchors. That is not a small job. Long Tabas. Elion watched from orbit as New Mombasa's local feeds filled with quiet debates. Most residents did not yet blame Lemuria by name. They had other words: plate shift, tectonic drift, deep uplift. Still, the idea spread. The deep ones are under us, a child said in a clip that made its way into global streams, pointing at the ground. Her grandfather laughed, but his eyes were troubled. New Mombasa was only the start. Around the Indian Ocean, dozens of coastal zones began to feel similar. Tiny changes. In some places, land rose just enough to push beaches outward. In others, subtle tilts made wetlands flood more often. Floating ocean cities with their flexible moorings adjusted more easily, but even they felt slow tension in their tether anchors and deep supports. "We expected some of this," Sarah said to Elion during a council briefing. "We just did not expect it to begin so soon. Lemuria's timelines may be shortening," he said, "or our measurements are finally sensitive enough to see changes that were invisible before." Either way, Councillor Gian said, "This is no longer abstract. People will have to move, rebuild, spend. They will want to know who chose this, us, them, or no one. No one chose tectonics," Elion said softly, "but someone is steering them now, at least in part." The phrase hung in the air, steering tectonics. Once that had sounded like fantasy. Now it was a daily factor in budget meetings. While the crust adjusted, the conversation between surface and depth took on a new tone. The boundary message the Lemurian language group had crafted went out in long loops through neutrino beams and microquakes. It painted a coded map of Earth, dense blocks where billions lived, sparser zones, claimed industrial belts, empty stretches. Lemuria answered. Its reply was not a neat, obvious symbol. It was a change in how it moved. Over several months, uplift slowed under bright human clusters and increased under darker patches. Strain maps showed clear corridors where Lemuria seemed to accept more stress, under empty ocean ridges, under parts of Antarctica, under low-population continental zones. Where human lights were thickest, motions nearly halted. "Look here," Sarah said to Elion, highlighting a map of Southeast Asia. "This arc of islands is crowded. Old data suggested they would see significant uplift. Now, almost flat. The excess has been redirected along this deep water band instead." "So they listened," Elion said. Naima, watching the same model from a different continent, nodded slowly. "They did not accept all our claims," she said. "Some of our we will work here zones still see stress, but they acknowledged our densest population centers and shifted around them. That is, not nothing." General Ortiz did not look convinced. "They chose where to make room," he said. "We did not. That still leaves whole coasts that will have to retreat over the next century. Try telling those people that Lemuria is being considerate." No one had a good answer. Kamal spoke after a moment. "Taking others into account does not guarantee fairness," he said. "It only shows that the other party recognizes you as something more than background noise. That recognition is an opening, not a victory. On the ground, recognition or not, people faced practical questions. Coastal councils began to draft new deep uplift adaptation plans. These were thick documents full of maps and timeframes, zones to reinforce, zones to phase out, zones to convert from fixed infrastructure to floating. They had 3 columns for cause: 2, standard tectonic risk; 3, Lemurian-induced strain. The third was the hardest to sell. Telling a fishing community that their village had to move because of storms made sense. Telling them it had to move because an ancient deep civilization was slowly raising the crust under someone else's coastline was harder. In a port town on Madagascar's east side, a meeting captured by a local feed showed the tension clearly. "They say the ground here is safe," an older woman said, tapping the map. "But my niece in the north must leave her home because the deep ones chose to push there instead." She snorted. Long. Rumisperstortrebribe, huesterebird. A neighbor younger, wearing a Lemuria patterned jacket, shrugged. "No one," he said. But no one asked the ice before it melted either. Things move. We move. Stories like this multiplied. Long. Elion watched them, heart heavy. "We are already in competition, and we have not shared a single physical space yet," he said to Sarah. "We are just sharing strain." Global councils realized they had to speak more directly, not only to their own people, but also to Lemuria. Humans had sent greetings, maps, timelines. They had not yet sent demands. Some feared demands would look like threats. Others argued that staying polite and vague would make humans seem weak. What is a demand in neutrino patterns? Kamal asked dryly in a planning meeting. Any signal that says do this instead of this is? Hadaya answered. That is where we are now, Jian said. We must say do not push here, slow there. Give us time in this region. In return, we will give you room in that direction. Orthodox diplomats, used to dealing with human states, felt lost. How do you negotiate with something that did not have obvious borders, governments, or individual leaders? Naima tried to frame it simply. Think in terms of overlapping fields, she said. We have preferences for certain zones and times. Lemuria has preferences for others. Our task is to align them enough that both can function. To do that, we must first know our own limits, Kamal added. How much can we really move? How much must we protect? We cannot ask more from Lemuria than we ask from ourselves. Elion thought of New Mombasa and the Madagascar villages. If humans could not even agree on how to share burdens among themselves, asking a deep civilization to share fairly felt ambitious. Still, they had to start. The Lemurian language group designed a request signal. It used patterns they thought Lemuria now recognized, the surface life tag, the machine interaction marker, the timeline segments, and the new boundary map blocks. They formed a kind of sentence. 1. Marker for surface civilization. 2. Block representing a dense coastal human zone where uplift was starting to hurt. Pattern for less or slow, borrowed from internal Lemurian segments that coincided with reduced stress. Long, 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 long. 4. Block representing an empty ocean ridge zone. 5. Pattern for more or okay. Long, 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 long. 6. Marker for we will move industry here, a combination of human fusion and construction tags. They sent this sequence again and again, through neutrino beams cutting Lemuria, and through microquakes under agreed sacrificial zones. Long, 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 long. It was not just please, it was please do less here, more there, and we will help make that second zone useful. Lemuria's reply was not instant. It came as a slow bending of stress lines. Over the next few months, uplift under the named coastal zone eased slightly. Stress under the target ridge zone increased. Fusion mining maps, adjusted accordingly, shifted future projects toward that ridge. That looks like an answer, Sarah said in a joint call, watching the maps side by side. They accepted the trade, at least partially. Or their own plan already matched ours, Kamal said. But yes, the correlation is strong. General Ortiz surprised everyone by sounding almost hopeful. Then we have something to work with, he said. We may never be able to make them stop rising, but we can at least shape where and how fast. That is, more control than I thought possible a year ago. Kamal smiled faintly. It is not control, he said. It is influence, shared influence, on a world bigger and older than both of us. While councils and AIs shaped these signals, the deep physical connection between species also tightened. In one sense, humans and Lemurians remained far apart. No Lemurian body rose into water or air. No human craft penetrated Lemuria's outer shell. Yet in another sense, they were closer than any two civilizations had ever been. Human cities, ports, and farms lay on a crust that Lemuria now pushed and braced deliberately. Lemuria's shells, anchors, and heat systems took into account where humans had dug, drilled, and altered. Even without a shared language, they were co-engineering a planet. Sometimes clumsily, sometimes well, a new field emerged almost overnight: dual civilizational design. At engineering institutes, young students took courses with names like tectonic coexistence planning, your shared mantle crust systems, ethics of deep earth collaboration, your shared mantle crust systems, of Naima. He floated in front of a hollow representing Earth's cross-section. Hundreds of faces watched from different nodes. People call this a conflict, he told them. And it is, two species needing the same stable crust. But it is also a collaboration, whether we like it or not. Every adjustment Lemuria makes now has to consider us. Every adaptation we make has to consider them. You will design structures that bend with deep stresses we did not choose. You will plan cities that can shift over decades. You will build sensors that let future generations remember why the ground moves. A student raised a hand. Do you think we will ever see them? She asked. Not just patterns, but actual Lemurians? Lilian hesitated. Maybe, he said. But if we do, it will be at a cost. For them to come near the surface, they will need conditions we do not naturally provide. Heat, pressure, chemistry. Any space that suits both of us physically will be an unnatural compromise. We should not rush that. We must learn to live with their presence long before we share a room. As contact deepened, so did fear. Some humans wanted more from Lemuria: knowledge, technology, even guidance. Others wanted less, a clear separation, or a way to force the deep structure to stay put. Movements formed around both wishes. The second founders' groups held vigils above Lemurian corridors, sending simple gratitude pulses down with home-built neutrino devices. They called Lemurians our elder cousins. Without them, one leader said in a broadcast, Earth's climate might have gone wild long ago. We owe them for the stable window we evolved in. Opposing them were the sovereign Earth factions. To them, Lemuria was an invader. It does not matter who came first, a sovereign Earth organizer said. We are here now. We live on the surface. This is our world. If the deep structure threatens that, we must find a way to stop it. They pushed for research into countermeasures, ways to diffuse Lemurian stress, disrupt their magnetic locks, overload their systems. Most scientists refused to help. We do not know enough, Jana said bluntly in one such hearing. Any attempt to jam Lemuria now could trigger uncontrolled motions. If they fall or lurch, whole continents could suffer. This is not like disabling a satellite. No, Elion said. We are not helpless. We are in a relationship. That is messier than war, but also safer, if we manage it with care. His words did not change all minds, but they did add a third current to the public mood. Not worship, not defiance, but wary, steady engagement. Years passed. The slow uprising continued. In the Indian Ocean, some mid-ocean ridges rose high enough that new islands peeked through the waves. They were small at first, bare rock, sprayed by waves, ringed by curious birds. Humans moved quickly to tag them. A joint human-Lemurian advisory council named them with paired terms, one from local languages, one from an agreed Lemurian code pattern. Maps began to show entries like Naya Kisiwa/LAV217, new island chain in Central Basin, designated Shared Adaptation Zone, Gond Ridge, LAV2 Stabilized Uplift Zone, Limited Human Use Agreement. No Lemurian would ever stand on those islands, but the act of naming them together mattered. It was the first time official documents described any place on Earth as shared between surface and mantle civilizations. With each new negotiation, the structure of the relationship grew more complex. Some patterns became routine, humans shutting down or rerouting certain deep projects before they caused problematic stress. Lemuria delaying uplift in zones where human relocation was behind schedule. Both sides adjusting for unexpected events. A large natural quake in a distant trench. A solar storm that rattled both crust and field. Sometimes errors occurred. Once a mistimed human microquake test overlapped with a Lemurian internal cycle in a bad way. The result was a cluster of slightly larger than expected quakes along a quiet fault, damaging several towns. For days after, Lemuria's neutrino patterns went flat, as if sulking. We stepped on their toes, Hadia said. They stepped on our houses, one of Ortiz's aides snapped. Neither side had intended harm. Both sides learned how small timing mistakes could have large consequences when two massive systems touched. They added new safety protocols. They apologized in code. Elion aged. Lines deepened on his face. His hair went more grey than black. He spent less time in the orbital lab and more in quieter analysis rooms, letting younger colleagues run the main dashboards. Still, no one else had quite his feel for how Lemuria and Earth's plates interacted. Your fingers see patterns before our AIs do, Sarah told him once, half teasing. Old fingers, he said. They remember many wiggles, she replied. He laughed. One day, after a long meeting, Sarah joined him by the station window. Below, the Indian Ocean glimmered, dotted with islands old and new. Somewhere under that water lay the vast, hidden continent that had changed his life. Do you ever wish we had never found them? Sarah asked quietly. Elion watched the faint line of new uplift along a mid-basin ridge. He thought of cities that had moved a little inland. He thought of whales circling in sync with a deep heartbeat. He thought of neutrino graphs that no longer looked lonely. No, he said at last. We always lived on this planet with them. Ignorance did not protect us. It just meant we could not prepare. Knowing hurts. But it also gives us a chance. A chance for what? She asked. To be better neighbors than we might have been, he said. Even if we never become friends. In his last years of active work, Elion served on the first formal interface council between humans and Lemuria. The word council was mostly symbolic. On the human side sat representatives from many regions, plus AIs and scientists. On Lemuria's side sat patterns. The interface council met not around a table but around a shared dataset. Sessions went like this. Humans proposed an adjustment, a request for slower uplift under a new agriculture belt, an offer to speed relocation from a certain coastal zone. These proposals were encoded in agreed Lemurian-style signals and sent. Over weeks, Lemuria's internal patterns changed. The council then interpreted those shifts as either acceptance, partial agreement, or refusal. Let all long to some more like reading weather than talking to a person. Yet over time, the back and forth built a rhythm. People began to speak of Lemuria's mood in casual ways. Calm, focused, uncertain. Kamal warned against too much projection. They are not a person, he said. They are a system. Perhaps many individuals, perhaps something stranger. But person-like words help us remember that there is agency there, not just physics. During one session, after a tense negotiation about a densely populated delta, the council agreed to accept more uplift there than they wanted, in exchange for extra time and help from Lemuria under a different coast. A coastal leader from that delta spoke afterward, her voice steady. "I do not like this," she said. "I do not like telling my people that we must move because a deep civilization and a panel far away decided it was the least worst option. But I like even less the idea that the ground moves and no one is steering anything. At least now, when we grieve, we can also plan." Elion felt the weight of her words. Shared power did not erase pain. It only gave it context. On a quiet shift near the end of his career, Elion found himself alone again with the station AI, looking at a new long-term projection. He had asked for a century-scale simulation, where Lemuria's upper shell would be relative to the crust in 100 years, assuming current trends. Long rotated slowly in front of him. Under the Indian Ocean, Lemuria's top bulged closer to the crust, but not yet touching. Around it, broad bands showed zones of heightened and reduced stress. Some coasts glowed with warning colors. Others, surprisingly, looked calmer than today, as forces redistributed. Under a few empty ocean stretches, Lemuria's shell nearly brushed the base of the crust. Contact points, the AI said. Projected earliest zones where Lemurian structures could influence shallow mantle directly under thin crust, without catastrophic failure. Could they send parts of themselves upward there? Elion asked. Unknown, the AI said. Material transitions between their environment and ours would be extreme, but those zones could support intermediary structures, pressure-staged. Liolon, he turned. Sarah floated in the doorway, older too, her hair almost entirely silver. "Everyone is gathering for your farewell," she said. "You are late to your own speech. I got distracted by multiple civilizations sharing a planet," he said. "You know how it is." She rolled her eyes. "Come on. They want to thank you before you vanish into quiet consulting." He glanced one last time at the model. Then he let it spin on without him. The farewell gathering was small, by global standards. A few dozens people in the orbital station's main hall. Hundreds more linked in from Earth. No Lemurians, except as patterns humming deep in the planet. Naima spoke first, then Hadia, then Rafi, then Kamal. They told stories of the day the deep penetration images first revealed the grid under the ocean, of the first weird neutrino reply, of the time Elion had insisted on recalculating a minor anomaly and uncovered a major shift. When it was his turn, Elion drifted to the center, held in place by a gentle field. He did not like speeches. He kept it simple. "When I was young," he said, "I thought of Earth as something big and mostly unchanging. Plates moved, but so slowly that no person could feel it in a lifetime. I wanted to know that hidden, quiet world. I thought that if we understood it well enough, we could predict everything that mattered for our safety. I was wrong. Understanding did not mean control. It meant seeing how small we are in time and space. When we found Lemuria, we found a second kind of smallness, being late arrivals on a world that had already seen one technological species. For a while, that thought crushed me. Then I realized something. We are not just small. We are loud. That makes us hard to predict, even for systems old and patient as Lemuria. That is not only a threat. Lond 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 It is also our contribution. A species that will not sit still can, if it chooses, move quickly to avoid harm, to adapt, to correct mistakes. Lemuria cannot do that. Its very nature is slow. It needs centuries to adjust what we can change in decades. So here is where we stand. Long. They have deep knowledge of rock and time. Long. Prepare. We have fast knowledge of change and adaptation. Earth needs both. Maybe, someday their shells will brush the crust, and some of them will rise into water, into chambers we shape together. Maybe they will never do that, and we will remain only pattern friends, each reading the other through stone. Either way, the planet we share is teaching us the same lesson. No one gets the whole world alone. Not us. Not us. Not them. That is a promise to take responsibility for the parts we touch. We have already broken that promise in our past. Now we have, perhaps, another chance. Do not waste it. You stopped, surprised to feel his throat tighten. The hall was quiet. Then slowly, people began to clap. Not loud, steady. Outside, earth turned. Beneath the applause, under their feet, Lemuria shifted in its own long cycles, unaware of the small ceremony, or perhaps aware in some diffused, coded way that another human life was stepping back from the front line. Years later, in a small coastal town that had moved once, and would likely move again, a child walked with a parent along a new seawall. Beyond the wall, the sea shone in late sunlight. Far on the horizon, faint silhouettes of floating structures marked the boundary of an agreed Lemurian corridor, a stretch of ocean left more empty of heavy buildings, to give room for future uplift. The child pointed. "Is that where the deep people are?" she asked. Her parent smiled. "They are under there somewhere," he said. "Deeper than any fish, deeper than the rock we stand on." "Do they like us?" she asked. He thought for a moment. "I do not know if they like or dislike the way we do," he said. "I think they know we are here. I think sometimes we annoy them. Sometimes we surprise them. Sometimes maybe we help them without knowing." "Do we like them?" she asked. He laughed softly. "Some of us do," he said. "Some of us are scared of them. Most of us are still getting used to the idea that we are not the only smart ones on this world." The child considered. "I like that they are there," she said. "It makes the ground feel less empty." She knelt and put her hand on the warm stone of the seawall. For a brief, silly moment, she imagined something far below feeling that touch. Of course, nothing happened. The rock stayed rock. But under it, in the mantle, faint stress lines carried tiny ripples from waves, from footsteps, from distant quakes. Those ripples joined others, forming a constant, low background hum inside Lemuria's shells. Within that hum, Lemurian systems sorted signals into classes. Natural noise, human patterns, their own control cycles. Somewhere in that deep mind, under different words and values, there existed a category that had not been there before. Surface civilization, fast, complex, co-occupant. Above, humans had their own new category. Long. Between those labels lay all the tension and hope of a shared planet. In the end, there was no final treaty. No clear line in the ground that said, here ends human Earth, here begins Lemurian Earth. Long, there was only a set of fragile, revisable arrangements. Shared zones where uplift and human projects intertwined. Sacrifice zones where coasts gave way so others could stay. Communication patterns that both sides updated as they learnt. There was also the constant risk that something, an unpredicted solar event, a mistimed human experiment, a Lemurian system failure, could throw the balance off. The future was not safe. It was also not doomed. It was simply open. As Elion lived out his quiet years on an ocean city far from the Indian basin, he sometimes woke at night and felt a soft tremor under his bed. Most were just waves or local ground settling. A few, very faint, matched Lemuria's deep cycles that he still checked now and then out of habit. When that happened, he lay awake and counted seconds between pulses. the way he had once counted seismic arrivals after distant quakes, a heartbeat of stone, far too slow to match his own, but there, he would think then, not of battles lost or avoided, not of coasts or codes, but of the simple fact that for this brief span in geological time, two thinking systems had overlapped on a single world. That overlap might end someday. Humans might leave Earth in part or in whole. Lemuria might finish its rise and enter a new steady state, or fail, or change beyond recognition. The planet itself would keep turning. Mantle would still churn. New continents would form and fade. But for a while, long for humans, short for rock, Earth had been more than a stage for separate stories. It had been a meeting place, a shared experiment, a lesson. Not that the universe was full of life, though maybe it was. Not that older civilizations were always wise, though Lemuria had its deep kind of wisdom. But that responsibility did not end at the surface. When you claimed a planet, you claimed all of it. Crust, mantle, core, histories you knew and histories you had yet to uncover. For generations after Elion was gone, children would learn in school that humans were not the first technological species on Earth, and that they had once almost wrecked their climate without knowing. They would also learn that, when faced with a slow, hidden neighbor waking under their feet, humans had done something new. Long. They had not tried to conquer at once. They had also not surrendered their needs. They had argued, adapted, reached out, pulled back, tried again. They had treated the planet, not as a prize to win, but as a home to negotiate. Whether that would be enough, only time and shifting stone could tell. The planet that had lied by omission for so long now carried two claimants, who knew about each other. Neither could erase the other easily without hurting themselves. So they stayed, wary, watching, adjusting, and Earth, Lumpsibili, and Earth, older than both, and patient beyond any plan, continued its slow work of carrying them around a modest star, as it had carried so much before. For now, at least, it held.